Plug in this device every month, so that's why it decides to update during the meetup. So while the presentation's going on, you guys can be entertained by the updating count of my Airtame device. So thank you for coming out to the meetup. I know during the summertime we don't get as big of a group, but we set up the same amount of chairs. So the quality does, I have to say. You are by far the best group we've had so far. So, no, especially you, Wayne. Especially you, Wayne. There we go. How many of this is your first LVTech meetup? Few, right? Okay, so that's like 3 honest answers. If you're not familiar, we do this basically once a month. Sometimes it's a deeper dive like tonight on a single topic. Sometimes it's 3 or so presenters talking about something that they've built. Other times we do like a panel thing. So we try to rotate it. Next month, we're not doing our normal, for those of you who are regulars, we're not doing our normal third Tuesday. It's going to be, it's going to be the 11th, which is a Sunday, and we'll be at the arena in downtown Allentown as a part of Lehigh Valley FAST, which stands for the Festival of Arts, Science, and Technology. It's something the Da Vinci Center does a similar event every other year for, I don't know what they call it, Science Fair Week or something like that. So imagine a really big science fair, but then we also brought in a lot of makers and gave it a maker fair feel at the same time. So that's going to go on, like I said, in the arena. Should be really, really cool. So I encourage all of you to come out to that. And if you want to be involved in that as a volunteer, certainly let me know as well. You know what, if you go to lehighvalleyfast.org or .com, one of those two, it'll redirect you to the page on Da Vinci's site, so which I don't know off the top of my head, but it's on Da Vinci's site with a little video. We'll be from 11 o'clock to 6 o'clock, no tickets to get in. And if you have something you would like to exhibit, like something you'd like to show off, let me know too. I'll give you the link to the sign-up form for that. As long as you're not selling something from the table, it's completely free. So if anybody, like I said, if anybody wants to be involved with that, let me know. I'll give some more information at the close of the meetup, but without me taking any more of your time, I'm going to turn it over to these two, and they're going to talk about big data and what Lehigh's doing with DataX. So
good evening. My name is Brian Davison. I'm an associate professor of computer science and engineering at Lehigh. Dan Lopresti is the other guy here from Lehigh, and he'll be presenting after I get us started. I'll let him introduce himself when he's ready. But today, to talk about big data and where things are going, let's start with a really cool example. So back in the 1980s, and that's why this image looks so bad, because it's digitized from a newspaper ad. This company didn't exist long enough to be on the web, and so anyway, Signet. There was a small Virginia bank called Signet Bank, and back then credit cards were offered by traditional banks at the one-size-fit-all kind of strategy, 19.8% rate and $20 a year annual fee. That was what everybody did, but you could have one with your own bank's name on it and get your personal line of credit and so on. The banks had access to consumer data. They had the information. It was flowing through their system about what was available to them, to what they were buying, but the banks didn't use it, they didn't capture it, and they certainly didn't record it and save it for later analysis. But Signet Bank did have a credit card, and in fact it looked something like that at one point, and they ended up hiring a small consulting firm. This is still back in the late 80s, run by 2 guys, Richard Fairbank and Nigel Morris, and they're here on the side. They had a consulting company that analyzed credit card risk. So they were quants or data analysts, analytics people. They wanted to learn what consumers wanted in terms of credit cards. And they were trying to convince the big banks to let them do this. Well, they couldn't find a big bank that wanted to let them play with their customers, but they found a small bank that would. So they experimented. They dropped the annual fee. They targeted different cards with different characteristics, the different segments of the population. This was really expensive. They, normally credit card companies have maybe a 3% loss rate from people not paying off their debts. Well, for a while, they got up to 6%, twice as much the loss. That's sort of expensive. But they were learning. They were collecting data. It was, in fact, useful data. And they said that this extra loss was just the cost of acquiring that knowledge, that data that let them learn things. Eventually, they compiled enough demographics and other data to make this a useful enterprise, to identify the profitable segments and figure out what the right pitches were to these different segments, and became a successful process. So successful that their business division was then spun out of Signet. And in 1994, you might recognize the company because they do a lot of advertising. So what's in your wallet, right? Capital One was born in 1994 out of this bank because they had been so successful. In fact, in just a few years later, in 1996, they had over $12 billion in loans. They had over 5,500 employees just in this company, just doing credit cards in these smaller markets, these more customized, targeted things. So some people say that Capital One's success is not because it's just a credit card business, but because it's really an information gathering company that offers credit cards. So it's a bit of a different perspective on what they do and what their intentions are, and then how they can leverage the information they've been gathering. But as you all know, soon other companies started to mimic their approaches, and so they really revolutionized the credit card industry. And now we all have credit cards with different characteristics that we want, miles or money back or low rates or whatever. Very cool. So yeah, that's how Capital One came to be. So just as an aside, what about the part of Signet, the main part, the bank? Did it disappear? No. It didn't go off as Capital One, but it got bought by First Union, which then merged with Wachovia, which then merged with Wells Fargo, and if you might be their customer today still. But in any case, Capital One is just one major example of the success of data-driven decision-making, right? They're looking at the data, figuring out how to target, how to make offers, and they started doing it back when 386s were popular and dial-up modems and floppy disks. Some of you might not have ever used those things. But again, they're just one example. Yes. But they're just one example of a company focused on understanding consumer preferences. And this understanding is what drives personalization, recommendation products, market segmentation, targeting. These days it also includes products that go on your grocery stores and where they go in the stores, what shelves they're on, how big, how much display space to give them. This is all very well controlled and highly analyzed data to optimize this for a particular market that the grocery store serves. Recommendation too is commonplace and can be found in lots of places like on Amazon, where you're constantly being told what else they think you might want to buy, or Netflix, where you're being told, hey, you like this, maybe you'd like that. And these things are possible because these companies have collected large amounts of data, big data, very helpful for tasks like this. But of course, it's not just the bigness of the data, it's not just because they have lots of data, it's rather the ability to extract actionable information from that data. And that we certainly saw that in the Capital One example, but it's certainly also true anywhere you see people talking about big data. It's not just the data, you got to get the information out as well. So I'm wearing a t-shirt from my time at Facebook. And in fact, another one of the examples of this kind of company, lots and lots of examples of personalization, recommendation at Facebook, where I spent a year while on sabbatical. And of course, Facebook's data is just massive, just mind-blowingly massive. Billions of users each month, the content activity logs are just tremendous. And all that data, hundreds of petabytes in a single data warehouse, is stored in their data centers around the world. This happens to be one of them. And they have enough computers that they actually design their own computers because they need them to be efficient and inexpensive, or less expensive perhaps. And they're very good at it. In fact, they're also good at building data centers, like this one in Sweden, that doesn't use air conditioning. Pretty cool, actually. Very efficient. So all the data that they have in fact, is available to people at the company. So when I was there, I was under NDA and everything else and some controls, but in fact, I could have access to like 99% of the data that was collected, that was there, and it truly was massive. So I could look at it, and in fact, it was used by other parts of Facebook to optimize, make recommendations, like in the news feed, to figure out what's the right thing to show you right now, and in a minute, it'll be something different, or even in a second, it'll be something different, because even if one of your friends posts something right now, in a second, they're gonna have it available and ranked appropriately so that it can be fitted into your news feed. Also deciding what ads to show and what recommendations in terms of groups and other parts of the service that they want to recommend that you join. Facebook had great data scientists, and I was very fortunate to be able to work with some of them, and data engineers and other data somethings, and they built some amazing software. They developed Hive, for example, which is now open source and used by lots of companies. The data warehouse technology lives on top of Hadoop, allows them to store and process really large data sets. It gives you the ability to write essentially SQL code and access these things as if they were databases. And much of the time while I was there, that's what I did, because that's where my data was, and I wrote SQL, HQL, Hive query language, but essentially SQL code to pull stuff out of one table and create a new table or update a new table and do that again and again until I got the data I wanted, and then I could extract and visualize or build some kind of feature from it. But since that was built on Hadoop, which, if you're familiar with Hadoop, requires a lot of disk I/O in between stages, it's sort of slow. And so for people who are doing more interactive things, they built something called Presto, which was intended to do it in memory and does most of those things in memory. And again, this is open source and designed to be running, an order of magnitude, if not more, faster than Hive did. And it does. And I used it, a variation of Presto and a variation of Hive when I was there. They open source both technologies, so other companies can use it, and they do. Dropbox uses it, Amazon, Netflix. Netflix did this little comparison, the execution time of some common tasks, and found anywhere between 10 and 100 times speed up. I mean, if you think about the architecture, doing it in memory versus doing it on disk, of course you're going to see tremendous improvements. But the fact that they could do so much in memory was really the key. I'm going to mention one more development that they had. Facebook runs, whether you like it or not, over 1,000 experiments every day. That means that if you're using Facebook, you're probably in at least one of those experiments, which means that your Facebook experience is not going to be the same as my Facebook experience or Dan's or anybody else. And this isn't just Facebook. Google's doing the same thing. And there's personalization, of course, involved here there too, so our experiences can be different. But in any case, they are a company that's driven by data. And so when they wanted to make a decision, they have to get data to support that. And when it's a decision about a product, a feature, a variation, they have to do an experiment, or they want to do an experiment, to justify making this change a permanent change. Now, you might have heard this as called an A/B experiment, and that's one kind of experiment that they do, but they have plenty of others. Might be the layout, or how prominently to put that little little red number up here. And apparently it needs to be pretty prominent. Bright red is what they wanted and got the right kind of interaction effects that people had and that's how they chose it. I'm quite certain of it. Please. Yeah. So 1% is too large. It is. When I was looking at data, I looked at 0.1%, and that was plenty big for finding any kind of significant statistics that I wanted out of it. I think that I don't know the actual answer to your question, but I know that it's going to be less than 1%, and it's typically a pretty small fraction. They're going to try to do this in as small of a group that they think that they'll still get the effect, be able to answer the question that they're trying to answer. And if, I wouldn't be surprised, wouldn't surprise me if this system called Plan Out actually helps in that process, because this system is designed to help you do these experiments in ways that keep you from making stupid statistical mistakes, keep you from having your experiments clobber somebody else's experiment. It happens, yeah. Or you might do an experiment and then a month later or 2 months later or 6 months later decide, oh, I want to do another experiment using the same group of people that I used last time because it's something that builds or whatever. And this makes it possible to do that in an easy way. And again, this was written by colleagues of mine in the core data science group, and it's been open sourced, and you can get it for Python. They do it in other languages too. But it depends. So I've seen some features, things that are already decided this is what we're going to do, but we're going to roll it out incrementally, and so they'll start it in New Zealand. You know, a small English-speaking country where they have a culture that's not so foreign, and be able to analyze how it goes, and then go on and grow it, and make sure that nothing's going to break in the process of growing a larger user base. It's just one, yeah, yeah. So I've said this phrase a few times, data scientist, and because I call my colleagues at Facebook, where I was working in the core data science group, they were all data scientists. And so you might ask, well, who is a data scientist? A couple of years ago, there was an article in Harvard Business Review that sort of proclaimed the coming of data scientists. And if you look at the second author of that article, small print, DJ Patil, people actually listened to him, because last year he became the chief data scientist of the United States, and which is where he still is right now. He did good things before that, and he was in good places. And then the lower one is from January of this year at Glassdoor, looking around and seeing that they categorize that highly as well. So what is a data scientist? The name data scientist and data science as a field is fuzzy, and you'll get different definitions from different people, but this kind of view is pretty popular, where data science is really not one field, but it's a combination of fields. And so in order to do good data science, or be really prepared to do data science well, you really need expertise in multiple areas. You need it in computer science, you certainly need a math and statistics background, and you need domain expertise. And so you can see that in the intersections, there are things that people or technologies or ideas that correspond to having some of those characteristics, but not all of them. So if you're a computer scientist who's really good at math and statistics, you might be a machine learning expert. But you might not know whether this is a good thing you've built or not, because you don't know about the domain. And that's the piece that's missing on the bottom. Or similarly, if you're a domain expert and a computer scientist, then you can build great applications because you know exactly what they want because you're a domain expert. But you can't build certain kinds of things. You won't be able to do the certain kinds of research that will be statistically important or valuable. And so I would argue that data science is really a team sport, because it's almost impossible to get someone who's truly expert in all of these areas. And in fact, this isn't all the areas. These are just sort of the major ones. If we were to add sociology, because almost everything we do, we need to interact and understand people. So let's add some sociology expertise in there. Maybe we need communications, because we need to present and convince people of what we're doing and get them to buy in. Maybe you need legal skills and data management skills, and there's lots of things really. And in fact, when I was at Facebook, the people that were there, I was in the minority as a computer scientist. I was in a group of data scientists, 45, 50 people, and they were computational sociologists, computational psychologists, computational statisticians, computational economists, as well as a few computer scientists in there. They all had computational training. They were all engineers in the sense that they were equipped and expected to contribute to the product and to code and to be building things, but that wasn't sort of their primary training. Their first training or their most significant training was in some other discipline. And the domain expertise, I've left it sort of blank because some places you might see this as business expertise. And those are people who are saying they're really thinking business intelligence or business analytics. And that's certainly one kind of domain, but in fact, it's much broader than that too. And that's part of the story that you'll hear from Dan about where we are at Lehigh. Because it can be vacation marketing or customer service or language evolution in the Middle Ages. All those things are domains that might benefit from the data science point of view, where you've got computational tools and doing statistical analyses and some doing very cool things for your domain. So this is where Lehigh comes in, and where I'm going to turn over the mic to Dan. Lehigh is here now partly because its ability to work across disciplines. That's one of our strengths. And Dan Lopresti is the department chair for computer science and engineering, my department. He's also director of the DataX initiative at Lehigh, and I'll let you hook things up while I ask if there are questions about what I've said. Any additional questions?
So, it's new, fairly new. I would say it's about, well, it would be under development for about 2 years, but sort of somewhat broadly known within the university for about a year. Yep. And I'll give you a little bit of the history. Although we've certainly had people like this at Lehigh for quite some time. So the characteristics that Brian described, in some sense, they're not completely brand new. This is existing in many people at the university, many of the students, many of the faculty over a substantial period of time, right? But some of these things have come together in new ways. Certainly our ability to deal with these massive quantities of data, having the techniques, having the technology, the networking bandwidth, the storage capacity, the computational capacity, those things have come together in the past few years, obviously. Right. Should say Brian is excellent. Brian came back from Facebook and said that there was this new discipline called data science. I think he said that. Said, I want to create a course on introduction to data science at Lehigh, and he did that. So for last year and going into this year, we've had introduction to data science, which Brian has taught. Now Brian is leading the effort towards developing a comprehensive data science oriented curriculum across not just our department, but across the whole university. And that will pull together a bunch of different areas that Brian would be happy to talk about, but we're in the process of having these discussions with our colleagues right now at the university. So I want to say that, as Brian said, I'm professor and chair of computer science and engineering, director of the initiative. A little over a year ago, I was also the interim dean of engineering. We've gone through a couple of interim deans before finding a permanent replacement for our previous dean who left to go to another university. So I'm going to give you an overview, and I've got, I pulled together slides from different presentations I've given to trustees and alumni groups and donors and faculty. So I pulled together some slides, I created some new ones based on some recent developments, and there are too many, so I'll go through some of them fairly quickly unless there are questions and we can go back to them. But basically, we're talking about the DataX initiative. From the university's perspective, it's a university-wide initiative. It's not just an engineering initiative. It's not a computer science initiative. It's the entire university, though it is largely aimed in computing and data analytics for sure, and will involve creating new faculty positions. So normally in a university, when we hire new faculty, it's because someone either died, they retired, or they left to go somewhere else, right? So our faculty are tied to the number of our undergraduate students. So long as Lehigh's got 4,800 undergraduates, that's the corresponding number of faculty we'll have, right? That's the way we pay our faculty, is via undergraduate tuition, even though obviously a lot of them are engaged in research, outside research as well. But these are new positions. So meaning the intention is that we're finding new money for them in various ways, and a portion of that certainly is via a very strong interest from some big donors who are interested in seeing Lehigh move forward in this regard. The targeted areas, sort of the core areas, are computer science and engineering, and certain aspects that focus specifically on computing and data analytics. but also 3 focus areas that we decided to start with, things that we are already strong with at Lehigh that are very interdisciplinary. We're very proud of being interdisciplinary. Consumer analytics, digital media, and connected health. And I probably don't have to say too much about any of those areas for you to understand what that might mean. You know, where does Facebook and Google make their money? It's largely through understanding consumers, understanding users, and making use of that information. Digital media, if you've been watching the Olympics, you've been probably watching it on not only your TV, but maybe on your smartphone, maybe on your tablet, right? The delivery of that information is a combination of consumer analytics and digital media. And connected health is pretty obvious the way the world of health is transforming now with all of the devices, you know, whether they're smartphones, whether they're things like Fitbits or Jawbones or even personalized medicine for that matter, would be connected health. But there are also, I should say, you know, in addition to the faculty that would, maybe we can, I don't know if we can, the sun shows a really good time to come out. In addition to those hires, like I said, there's a lot of faculty already at Lehigh who have this characteristic, and there are a lot of searches that are taking place that aren't nominally DataX searches, but have that profile. So we just lured away a very senior person in computational biology from a university, from a Midwestern university, who will be joining our Department of Biological Sciences. Very much a profile of DataX, although he wasn't hired under official DataX money, but that doesn't matter really, because at the end of the day, we're all Lehigh University faculty. So this is a university-wide initiative. The trustees regard it as one of the significant things we're doing. It might be one of the biggest things we've done in the last 20, 30 years at the university. It's combined with another very, very big initiative that I'll be talking about in a couple minutes. And we've already kicked it off. So we started it basically about a year ago through some hiring that I'll mention, and it's continuing into the coming year. So some of this is driven by the demand from the students, right? Brian told about the massive potential of data science and computing and all the ways it's being applied. But the students are seeing this as well, right? Students are very practical. They come to Lehigh. They want to learn things that will help them in their future lives. And many of them also are interested in things that will help them in their future careers. Brian mentioned that more than one source has identified data science and computer science as being really, really important and incredibly high demand. And the students are sort of voting with their feet. So at this point in the department, if you combine the various majors we've got, and the one nice thing about our department is we span the 3 undergraduate colleges at Lehigh. Some of you might know that Lehigh's got 3 undergraduate colleges: engineering, arts and sciences, and business. And we have very strong connections across all 3. In fact, I would wager that we're actually unique in that regard. We're the only department in the entire university that has strong connections across all 3 undergraduate colleges. So across all of our various majors, we have on the order of about 400 majors in computer science and engineering at this point, which makes us maybe not the biggest department, but very close to the biggest department at the university. And certainly the most rapidly growing, because we've doubled the number of majors over the past 5 years. And even from a very high plateau, we're seeing increases of like 7-10% a year. It's got to stop at some point. There's no point. At some point, we can't have all the majors, but we're getting somewhat close to that. Course enrollments, because it's not only majors in computer science and engineering that are taking our courses, but students across the whole university. So we have actually shows fall 16, which is the semester we're about to enter into. Once the dust settles, I suspect that number will be higher than fall of 15. And again, these are numbers that are doubling over a period of 5 years and increasing by tens of % over previous years as well. So at this point, something like 15 to 20% of all Lehigh undergraduates are taking a computer science engineering course this fall. And something like 6% of all Lehigh undergrads are taking our intro course this fall. So the enrollments are tremendously exploding. That's not unique to Lehigh, by the way. So right now, computer science is the most popular major at Stanford. That might not be a surprise. Intro to computer science is actually the most popular course at Harvard. But that might be a little bit more surprising because Harvard's a very traditional school with tremendous strengths in a bunch of different areas. Computer science is also now the most popular major at Princeton. I could probably rattle off a whole bunch of other schools where it is the #1 major at this point. And as I said, it's not just hitting computer science students, but across the whole university. So if you look at those are the different colleges at Lehigh, RCES is engineering, CBE is business, and CAS is arts and sciences. This is just our intro courses. It's basically saying students from all the colleges are taking our intro courses. And then Also, in terms of majors and non-majors, we have more non-majors taking our intro courses than majors, right? Because these students want to mix computer science with everything else that we offer at Lehigh, which is wonderful. We love to see that, and we make that very, very doable. Brian's data science course doesn't have quite the high enrollment that the intro courses have got, but it's got that potential too because it's accessible to all of the students. So this is data from the Bureau of Labor Statistics, United States government, right? So this sort of focuses on the STEM field, and it says over a 10-year period, all the new jobs that didn't exist before, the jobs we're inventing now, like think of the way Uber didn't exist before or Facebook didn't exist before, right? 65% of the STEM jobs are in computing, right, which dominates all the other STEM fields. You hear about STEM being, a big driver of economic activity, but within STEM, there's no question the 800-pound gorilla in the room is computing, right? That dwarfs life sciences, dwarfs engineering, dwarfs math, dwarf all of those areas. Yep. I would be, so this is a Bureau of Labor Statistics, anything that's sort of computing, that would put in a computing-related bucket, and the only way you know whether it is or isn't is like whether it would more naturally fall into one of the other buckets, probably, right? So, but the lines are a bit blurry there, so. This is something you can't read, but right. I love this graphic, by the way. You make this visualization work a little bit better, right? This actually goes back. I was surprised to discover this a couple weeks ago. That this goes back like 20 years. I'll tell you what this is saying, and then you can look at it later. It's actually from the National Academies, and it's showing the synergies between university research and academic research, which is really very cool. So normally imagine the sort of industry living by itself and universities living by itself. So we actually use this when we go down to Washington and we talk to our various congressional representatives, and I've done that for a number of years, and I'll be doing that in September. So some of the leaders in the government, in Congress, in the Senate and the House, they'll look at a company like Apple and they'll think that Apple invented all of that cool technology all by themselves. Right? So we just need to make things good for business in the US, and it'll all take care of itself because Apple will go out and invent all of the cool stuff, right? And they think that universities really don't have much of a role in this. But the fact is, if you look at whether it's Facebook or Google or Apple or any of the cool stuff that's invented, there's always components of it, sometimes very, very important components of it, that were invented in universities, right? And then transitioned to industry over time. Sometimes the work starts in industry first. So if you look at again, it's called the tire check chart. I apologize for not being able to read it. But in some cases, the research started in industry and then sort of moved to academia. Sometimes it starts in academia and moves to industry. And there's always a flow between the two. Like Brian mentioned, he spent a year at Facebook, right? Well, in the field of computer science, that's really, really, really common. The ideas and the people flow between universities and industry and universities. So the point of this story is that there's tremendous strength in the U.S. economy as a result of this juggernaut, and it's because of the synergies between research and universities and an industry. Not that it doesn't happen in other fields as well, but if you look at, they call this information technology, right? IT is what the government calls it. It's probably pretty unique in our field to see this movement back and forth and back and forth. So this is, I don't have to tell you about the impact of data across our society. So you're talking about jet engines that are generating a terabyte of data per, actually, I think it's more than just a flight. It's actually probably a terabyte per hour, I'm guessing. Connected vehicles now, we're talking about self-driving cars, largely which will achieve their capability through obviously tremendous advances in computer vision, control systems, but also through connected information flows as well, life sciences, sports and media. Obviously, we're seeing this play out in the Olympics in a very, very big way. So data is everywhere, connectivity is everywhere, computing is everywhere. This is a sort of more of a snapshot of what would happen at Lehigh if you sort of go to some of the very core activities, for example, in chemistry and chemical engineering and nanotechnology and bioengineering at Lehigh. We've got great faculty in those areas, up to the level of building devices, medical devices or sensors, new sensing technologies, photonics, new mobile technologies, and all the way up to the analytics and the computing. Basically, it's a vertical where we want to have capabilities at all levels of this process, right? So we can take advantage of all aspects of this. So, DataX in some sense is very new, but it builds on tremendous strengths at Lehigh as well. There's also a tremendous amount of activity in this area you may or may not be aware of, but you can't pick a major university that isn't making a major investment in computing and data science. You'll hear about schools like Harvard doubling their faculty in computer science. Schools that already are pretty big, like Princeton, increasing the size of their faculty by 25%, right? So this is happening everywhere. So I just want to tell you a little bit about what we were able to do this last year. So we went into a very competitive hiring market. That's the other thing. In some disciplines you're competing with other excellent universities. Here, when we try to hire a new faculty member, we're competing with not just other great universities, we're competing with Facebook and Google, right, and Apple and Microsoft, as well as all the other options that faculty members can have. We opened up a total of 7 faculty searches. Actually, 6 of them were officially DataX searches, and we were successful in 5 of those 6 searches, which I think is tremendously cool. Most of the searches were very strongly interdisciplinary in the area of consumer analytics, digital media, and connected health. One in each of the sort of the CSE side and then the domain side. Brian mentioned domain expertise, and then one in the area of core computer science. That's the one where we were not yet successful, although there's still a possibility that search will fill successfully. We hired some really great people. I'm not going to go through all of their expertise, but they're great places, really interesting multidisciplinary, interdisciplinary backgrounds, and it's really great that they're going to be joining us at Lehigh, in this case joining the college, the Department of Marketing and the College of Business, but with a very strong engineering background, joining the Department of Journalism with tremendous interest in social media analytics and communications. Joining our Department of Computer Science and Engineering, this is a young faculty member who does work on heterogeneous data mining. Some really cool stuff. We'll be teaching a course this fall on text mining. A new member who will be joining us in the spring of this coming year because he's finishing a postdoc at Cornell. And we do some he's a computational social scientist. So you heard that, Brian mentioned that particular discipline. He'll be joining us in computer science and engineering. And then another young faculty member who will be joining us next year who does tremendous work in computer vision and in computational, biomedical image analysis. And she did her PhD at University of Utah, and she's in a postdoc at MIT right now, which she's finishing up with one of the top names in the field of computer vision. So I want to say some things that are relevant with respect to interactions with you all across the Lehigh Valley, because obviously we're tremendously synergistic with what goes on in the Valley, and you guys are synergistic with us. DataX doesn't just support hiring these new faculty, but we have invited speakers coming through, so top researchers from around the country. You can see from Georgia Tech, from Columbia, from Drexel, from IBM TJ Watson, from Singapore. These are actually public talks that you're welcome to attend. So if you'd like to get on the mailing list, there's going to be typically maybe one of these every week or two. Just send me your email address and we'll add you to the seminar mailing list. We're very happy to do that. They're open. They're on the lower campus and often in Packard Lab, but not always. Something else you might be interested in is for our students, specifically for our students, those are sort of research-oriented talks, right? For our students, we have what we call Brown Bag Lunch Series. So this is so they can directly interact with people who are leading often small companies, but are doing really cool things out there. So that when those students go out looking for jobs, they don't think that their only option is like Google or KPMG, right? Those are the companies they've heard of, Facebook, Google, Microsoft. How are they going to find out what companies like DreamIt, or that's actually an incubator down in Philadelphia, some of you might know that, but All Computers Go, OSI Soft, Innovated Systems, which is a Pittsburgh company, right? How are they going to find out what it would be like to work for a company like that? So we've got this Brown Bag Lunch Series that's been very popular with the students. And then also, last year we ran a symposium where we had the president of NBC Olympics. Obviously, Olympics are going right now, but he was here at Lehigh on April 1st. That was a public event. We're planning to do another one, the symposium in the spring as well. So it was a full day of experts from around the country speaking on the convergence between computing, digital media, and consumer analytics. And again, if you're on the mailing list for the department, you'll get that as well. That's some of the stuff that we're doing. I'm not going to, this is sort of the stuff that we're planning as we ramp up the faculty. And as I said, Brian's leading one of the most significant efforts in terms of developing a data science curriculum. I do want to speak a little bit about the one other thing that's going on. I realize I've maybe spoken for long, and that is tell you that very shortly the traffic up here is going to get a little bit worse, right? Because we're in the process of a major renovation of the building that's just right over there. Building C, Mountaintop Building C. So some of you might recognize this aerial photograph, right? So you see Iacocca Hall, probably a lot of you have been in Iacocca Hall. We're about 417 feet away. I measured that earlier today. The building that's circled is that big building that's just over that way, right? That's Mountaintop Building C. Building B and Building C were the last two buildings that were held on by the steel company and that were acquired by the Indian company that bought the assets of Bethlehem Steel. And about 3 years ago, they decided that they were never going to use the buildings again. So what they did was about 10 or 12 years ago, they shut the buildings down. I guess they fired everyone, locked the doors, and basically said, well, we'll keep them, maybe we'll use them at some point. Now, Lehigh owned the land. So far as I know, we own all the land up here. I think we might even own the land this building's on if we don't own the building, but yeah. So we were going to get them eventually, but the Indian steel company that bought the assets of Bethlehem Steel said, okay, we're never going to use this again. Do you want them? And we went inside and we saw the conditions of the buildings that had been sitting basically locked, unoccupied for about 10 years. And we decided to take occupancy at that point in time. Oh, by the way, this is an ad from 1966. This shows an overview of the Mountaintop Complex, which, so far as I can tell, looks a little cleaner, but it's identical, at least in terms of the buildings, to the way it looks today, right? Yeah, parts of it. I guess it's built off the back. It's built off the back of that one right there, right? Yeah, yeah. So there's certainly stuff that's happened up here, significant stuff. But you can even see the Atlas, the building where Atlas is located over there, right? And so everything is pretty much the same as it was, except it is a little dirtier now, I think, or maybe it's a patina, we would say, right? And they were very proudly trumpeting that they'd spent $50 million on this facility. It was actually built, I think, starting in the early 60s, so this is a few years after they finished it. Anyway, this is what we found, some of what we found when I was one of the first group of people to go into the Building C after we acquired it, right? So literally amongst the first five people that went into the building, and these are the pictures I took on that first day. I think it was the first day, which was May 2nd of 2013. And you can see that they left behind hundreds of tons of stuff that was just sitting there for about a decade. They left behind hundreds of computers, dozens of file cabinets that were filled with files, thousands of engineering drawings. There was a lot of damage to the building. You can sort of see in the lower corner, there were pits in the floor that were filled with liquid and all kinds of stuff that looked really dangerous, right? So that was the condition about 3 years ago. Oh, in the interim, by the way, you probably know that we cleaned it up and we've been using it every summer for a program we call the Mountaintop Experience. Very interdisciplinary. Students from across the entire university propose projects with other students, and then faculty sort of serve as mentors. We don't tell them what to do, but the students do their own thing. And we've gotten a lot of attention for the summer program. It's gotten written up in the New York Times and the Washington Post. It's been very, very popular across the university. And these buildings will still serve that purpose. They'll still support that mountaintop experience, which has really become a really big thing at Lehigh. And every year, more and more students get involved. This year, about 150 students were involved, and dozens of faculty members were involved. So we expect to see that continue. But this is what now it's starting to look like. These pictures were taken a couple weeks ago on a tour. And the part of the building that's known as the Crescent, so there's 3 high bays, and then there's the Crescent where the offices and the labs used to be, has been completely cleaned out, as you can see. All the walls have been knocked down. And we're preparing for what is going to be the major renovation to help this building support the Data X initiative and the CSE department. So right now we're located in Packard Lab, my department, all the faculty and the graduate students. And once the renovation is completed, we'll be moving up here. So just like biology is located over there, chemical engineering is located over there, and the College of Education is located over there, a third department or a fourth department, if you will, we'll be moving up here in a little over a year once we complete that, as well as the Data X initiative. And as I said, the building will continue to support the Mountaintop initiative as well. So there's a lot of details about the renovation that are really exciting and really cool, and I could talk about it for a very long time. At the end of the day, it's an enormous building. It's well over 100,000 square feet. We're not going to be doing anything significant inside the high bays. They're going to remain high bays. They're going to remain those big, open, flexible spaces. In fact, the first time I walked into the building, I said, this looks like some space that Google would use or Facebook would use, right? And I said, we should do a hackathon in here. I also said this would be a really cool place to do mobile robotics, right? And that first summer, I got a quadrotor and I was flying it back and forth in the high bays, which is really quite cool. We did a hackathon last spring associated with the symposium, and we're on the verge of a major renovation. We started a major renovation that will make this building, the DataX building, among other things. But we're only really renovating about 80% of the Crescent, and like I said, we're not really touching the high bays. And there's a lot of future, to be decided, both with respect to building C, and also building B, which is that other building next to building C that we got that's currently empty too. So we'll have a first-rate telepresence classroom in the building. This will allow links between upper campus and lower campus, and also between here and the West Coast, and also New York City. We're partnering with some friends on that. You can probably guess the names of the friends. There's a lot of really cool architecture in the building. If you're familiar with the building, it's the Crescent. You may or may not know the Crescent is 3 floors. The upper floor actually overhangs the middle floor by about 10 feet. So what we're going to do is we're going to knock out the wall on the second floor and build basically a glass-lined corridor the entire length of the Crescent that will look out to that green area between building C and Iacocca. There's this large central green area. That's going to become a glass wall, which you're seeing on the right. That will become an outer hallway in the building. That will be the hallway now. They'll be moved from the middle of the building to the outer part of the building. And then punch through the walls, so there'll be a lot of shared collaborative space in this building as well. So it's a place where people from a whole variety of disciplines can come and collaborate and work and be social and do all kinds of things. This is more views of the collaborative space. And then in addition to the telepresence classroom, there'll also be an active learning classroom in there, as well as about a dozen conference rooms of all different sizes, rooms that hold anywhere from like 4 people up to the biggest one, about 20 people. One of the neat features we're going to do, as you can imagine, in the high bay space, that's where really dangerous, loud, noisy work was taking place. That's where the steel research was taking place. So there are very serious walls between that part of the building and sort of cordoning it off from the rest of the building where the offices and labs were. We don't need that anymore. In fact, we don't want that. We actually want to punch through those walls in a way that creates visibility between the Crescent and the high base. And that's exactly what we're going to be doing. So you're going to see an example of one of these structures that's going to puncture all the way through to the other side. So there are actually 4 walls of glass between the high bay where we're standing and the green on the other side, including that academic boulevard that's glass lined. This is a cross section of that structure that we call mixing boxes, right? And this is an image inside the mixing box looking out into the high bay. So it's going to become it's already a really, really cool building, but it's going to become amazingly iconic. So you're going to see people are going to see pictures of this, and they're going to say, that's Lehigh, right? So this is a view from Iacocca looking towards the building and then looking through that new glass portal that will look all the way through into the high bay, right? So I think and then there also will be a new entry complex as well. So this will be, there's a very small kind of ugly parking lot between building C and building B, right? That will be converted into an entry that looks something like this. This isn't the final design, but it'll look something like this. So a large glass atrium that will welcome people into the building. So that's what I had to tell you. Obviously, this is, as I said, this is one of the biggest things that Lehigh's done in 20 or more years. And it's just the beginning of it. And you're seeing stuff that, for example, this is not on the website, right? So this is in terms of the renovation or in terms of the initiative? Well, yeah, so for a while we've been targeting fall of 17. So not this fall, but next fall, a little over a year from now. For most of the renovation, this part right here, the entry might be winter of 18, right? As of right now, I think we're still on that schedule. Some of you might know that the summer students were up there until last Friday. Last Friday was the official day that they had to be out, so they're out of the building now, and as of now, the building is now totally in. They knocked down the walls in the Crescent because that was separate from the high bays. But as of right now, the building is totally in the hands of the contractors. And I noticed when I was driving up tonight, there's an American flag flying over the building which wasn't there before, which is a sign, of course, that they're doing the work now, right? So fall of 17 or winter of 18 in terms of the renovation. And then, what comes after that with respect to the physical facility, you can imagine this project is going to continue to roll for quite a while because we've got the rest of Building C as well as Building B, as well as some land up here. I'm telling you for the stuff for which there are actual plans, but, there's certainly some thinking going on for beyond that. So hopefully you all find that nice and exciting and cool. It's going to make a very big change. I think what happens up here is a beautiful space with tremendous potential and a lot of cool stuff going on, and now it's going to become that much bigger and better. So yeah, so we have all of those. So it'll be an interesting thing. One of the things we learned, so the grad students are coming up for sure. This will continue to support the undergraduate mountaintop experience, which is very strongly undergraduate focused. It does have some grad students. I should say, by the way, biology and chemical engineering already have their graduate programs up here as well. An interesting question is how much of the undergraduate activity starts to get pulled up here, right? So they typically have their research-oriented experiences with their undergrads, and like the senior project lab for chemical engineering are already up here. But it's a relatively small number of students. I mean, in terms of the entire Lehigh student body, we're obviously hoping and expecting to pull even more undergraduate activity up here over time. But another reason why we're building the telepresence classroom is to be able to communicate between upper campus and lower campus and eliminate some of the need for physical movement between the two campuses when we can do that.